Hello, my friends. How are you doing? So I think all of you are good and cool. You are together with Teacher Thomas. So welcome back to our YouTube channel of Chlorine TV Show. So today we are going to see how to oxidize hydrogen peroxide. And this question is all about redox titration, which is reduction and oxidation reaction. Today we have this question. A 25 centimeter cube portion of hydrogen peroxide was poured into a 250 centimeter cube volumetric flask and made up to the mark with distilled water. A 25.0 centimeter cube portion of this solution was acidified and titrated against 0.0200 mole decimeter cube potassium manganate solution. 38 centimeter tube of manganate solution was required to complete oxidation. Now our question is to calculate the concentration of origin. So before we start, if you are new on this channel, please try to click on subscribe, like, share, and even comment. So let's start our question. As I told you, this question is about reduction and oxidation reactions. First of all, we need to start by showing the half equations for hydrogen peroxide and for potassium permanganate. So let's start with hydrogen peroxide. First of all, as you know, this hydrogen peroxide is aqueous. So this gives oxygen, and this is gas, plus hydrogen. Remember here we have 2 hydrogen, you put here 2, then plus 2 electron. The next is to show the half equation for potassium permanganate. As you know, manganate, and even this is aqueous, this gives manganese 2 plus water. Here we are using water to balance this equation because in the question they told us it was acidified. So to balance in acid, so we have to use this water. Okay, now let's continue to balance this oxygen. You see that here you have 1 oxygen, but here we have 4 oxygen. That's why you have to put here 4. And now you see that we have 4 oxygen and hydrogen. Now it becomes 8. So you put here plus this 8 hydrogen, which are aqueous, plus. So we are going to balance our charges. You see that here you have 8 minus this one, it becomes 7. But here we have 2. That is 7 minus 2 to get 5 electrons. So you add it here. The next step is to balance now. We are going to balance our equation together. That is overall equation. So as you see, here we have 2 electrons. For here we have 5 electrons. So it means you put here 5 and here becomes 2. Now this 5 we multiply here to get 5 hydrogen peroxide. Still it is aqueous. Plus 2 multiplied here, it becomes 2 manganate. Plus 2 times 8 becomes 16H plus. And this gives here 5 multiply at oxygen, it becomes 5 oxygen, which is gas, plus again this 5 will multiply here to get 10 H plus, and this is aqueous, plus this 2 will multiply here to get 2 manganese, 2 plus, again plus 2 will multiply here to get 80 water. So we are going to first check if our equation is now balanced. So we have to start from charges. So you see that here you have 16, while here is 2 minus, that is 16 minus 2, it gives 14. On the other hand, we have 10, 2 times 2 is 4, also it is 14. So see that oxygen here you have 10, even here you have, this is 10. But here we have another 8, it means they are 18. Even here we have another 8, it means even here they are 18. Manganese, they are 2, even here they are 2. So it means our equation now is well balanced. Now the next step, we are going to start by calculating number of mole of potassium permanganate. Number of mole of potassium permanganate. Remember, this is aqueous. So is equal to concentration times volume. So you see that from above question, you see that we have 38 centimeter cube, means our volume is now in centimeter cube. But we have this concentration which is in mole per decimeter cube. It means we have to convert this centimeter cube to decimeter cube. So that's why you have to divide here by 1000. And this is equal to concentration. From above question, you see that our concentration is 0.0200, but it is more decimeter cube. Now we are going to multiply it by volume. You see that our volume is now 38. That is 38, but it is not in centimeter cube. Now it is in decimeter cube because we are going to divide here by 1000. So first of all, decimeter cube to decimeter cube means number of mole of manganate is now equal to, so let's use my calculator to find the answer. So you see that here you have 0.0200 times 38 equal, then divide by 1000, divide by 1000 equal. So let me click on tab. You see that our answer now is 7.6 times 10 power negative 4. 7.6 times 10 power negative 4, but this is more moles. Now we are going to determine the number of moles of hydrogen peroxide. To calculate the number of moles of hydrogen peroxide, from this overall equation, you see that 5 moles of hydrogen peroxide has been reacted with 2 moles of manganate. So it means 2 moles of manganate, 2 moles of manganate corresponds to 5 moles of hydrogen peroxide. So it means, as you can see, 2 moles of manganate corresponds to this number, that is 7.6 times 10 power negative 4 moles. When it becomes 1 mole of manganate, it will be this number, 7.6 times 10 power negative 4 moles, but divide by 2. Then when it becomes 5 moles of hydrogen peroxide, it will be this number, 7.6 times 10 power negative 4 mole, divide by 2 moles. Again, here is more times 5 moles. So this mole cancels this. So it means by now we have 7.6 times 10 power negative 4 moles times 5 divided by 2. Again, let's use our calculator. We are still having 7.6 times 10 power negative 4. You multiply here by 5 equal, then divide by 2 equal. Let me click on tab. that is 1.9 times 10 power negative 3 moles. So it means this is number of mole for hydrogen peroxide. So remember, our task is to calculate the concentration of origin hydrogen peroxide. So as we know, concentration of hydrogen peroxide equal N divided by volume. So remember here, we have this volume of 25 centimeter cube. Number of mole is here, 1.9 times 10 power negative 3. So it means you have to convert this volume to decimeter cube. So it means here you have to multiply by 1000. So this is equal to number of mole. You copy this number, 1.9 times 10 power negative 3 moles, divide by our volume, that is 25.0. Now it is in decimeter cube, then times 1000. So this gives, again let's use my calculator here. So still you have 1.9 times 10 power negative 3. First of all, we multiply here by 1000 equal, this is 1.9 divided by 25 equal. So you click on tab, that is 7.6 times 10 power negative 2. 7.6 times 10 power negative 2 more decimeter cube. So it means concentration of this is equal to 7.6 times 10 power negative 2 more decimeter cube. So this is our final answer. So thank you for watching this video, and I promise you that for every day we have to see at least one question in chemistry. And if you have any question in chemistry, you can tell us what is your question in the comments so that you can see it on the next video. Thanks for watching.